welcome. In this video session, let us learn about quantum numbers, the numbers which helps us to understand more about electrons. How do we think an atom is? Is it like our solar system, where the nucleus is in the center and the electrons are moving around it? Or is it more or less like a field where we have tracks on which electrons keep moving? And if at all there is a path, is the path narrow or is it broad? And if by chance electrons are moving in the path, can there be some kind of collision that can exist? Now, in this particular video, we will try to answer all these questions and try to know more about electrons. If you're talking about electrons, each electron in an atom can be given some kind of address. Now, these addresses are some kind of numbers, and we call these numbers as quantum numbers. Just like how our house would have a street name, city name, country name, and so on, there can be certain numbers which can tell us more about an electron. There are 4 such quantum numbers which helps to describe an electron completely. Now they are the principal quantum number, the azimuthal quantum number, the magnetic quantum number, and the spin quantum number. We will learn more about all these numbers in this session. Talking about the first one, which is the principal quantum number, we know that there is a central region in an atom which is called as the nucleus. Now we have already seen that nucleus is the site of protons and neutrons. Now the electrons are moving around this nucleus. Yes? Now, principal quantum number basically tells us one very important characteristic of the electrons, and that is the distance between the nucleus and the place where they are revolving around. Now, these are places which are called as the shells. Shells, you can just say that these are the pathways where the electrons keep moving around the nucleus. Say for example, the electron in this particular case has got two pathways to revolve around the nucleus. There is one which is pathway which is closer to the nucleus, and then there is one more pathway which is slightly farther. Now, if the electron is moving closer to the nucleus, we call that as a lower shell, which means to say it has a lower energy. The electron possesses lower energy. Whereas if the electron is moving farther from the nucleus, we call it as a higher shell, which means to say that the electron possesses higher energy. So basically, it is something like this. If the electron is moving in a lower shell, it can keep moving in the lower shell, but if energy is given to that, it can jump from the lower energy to a higher energy. Whereas if it jumps from a higher energy to the lower energy, then energy is released. And the energy is released is in the form of a small packet of energy which is called as the plankton. Now this particular pathway where the electron is moving around the nucleus possessing certain energy is what we call as a shell, and this pathway is numbered as n is equal to 1, n is equal to 2, and n is equal to 3 and so on. Now this value of n is nothing but our principal quantum number, which is denoted by n. Now basically this is telling us about the energy of an electron, hence it's also called as the energy level. This can range from 1 to the energy level of the valence electron. Now what is this number important for? Now this is going to tell us the average distance between the electron shell and the nucleus, and hence it is very important for us to know in which shell the electrons are present. So this is about the first quantum number, which is the principal quantum number. We have just seen that the electron is moving around the nucleus in a specific shell. If I take a cross-section of an atom, then I would see a picture very much similar to this. This picture clearly tells me that there is not a very specific pathway like what is shown in the first picture, but there is a region in which the electron can be seen. Now, there is one number that is given which is called as the azimuthal quantum number. Azimuthal quantum number is nothing but a mathematical probability where the electron can be seen around the nucleus. So, the electron can be seen, suppose this is the path, the electron can be seen here, it can be seen here, here, and so on. So, in this particular picture, you can see that finding the electron is maximum in the region where there is a dense cloud, and the probability of finding electron in its periphery is slightly less. So basically it is a number which tells me that the probability of finding the electron 90% of the time is somewhere in the dense region. Now this is what is called as azimuthal quantum number. So we can see that there can be the first shell where you see that the shell is very closely situated to the nucleus, which we call that as 1s, and then sometimes you can see that there are two shells, one here in this region and there is one more shell here, so we call that as 2s, and you can see that there are three shells here, one here, and one more here, we call that as 3s, and so on. So the probability of finding electrons is the maximum in this dense region. Now, if electron is moving in this pattern, is it always that the electron is moving in a circular motion? Now, that is not true, because the electron does not always move in a circular fashion. You can see that sometimes it takes a different shape, like a dumbbell shape. Sometimes you can see that the electron moving in the form of a double dumbbell shape, and there is one more complicated structure in which the electron can move around the nucleus. Now, basically, the azimuthal quantum number is different for each of these shapes. So basically, what is azimuthal quantum number telling me? It is telling me the shape of the movement of this electron. It can be spherical, circular, or it can be double dumbbell, or a much complicated structure. Subshells are nothing but the pathways that are followed by an electron inside a shell, and the shape of which can be circular or spherical, dumbbell, double dumbbell, and so on. So talking about azimuthal quantum number is also called as orbital quantum number or the angular quantum number. Now what does this let us know? This lets us know the orbital of an electron. When we talk about the orbital, it just means the shape of how the subshell is. Right? So that shape of the subshell is what we call as the orbital. This is a very important value because this helps us to know about the angular momentum of the atom. Now, why is it so important? It is because depending on what is the shape of the orbital, like a spherical, dumbbell or whatever, we see that it has a direct influence over the chemical bonds that they form, the bond angles that they form, which leads to deciphering many chemical compounds and their reactions. Now, always the value of this azimuthal quantum number ranges from L is equal to 1 to L is equal to minus 1. So, let me just explain this to you in a bit detail. So, we have if n is equal to 1, which is the lowest energy shell of an atom, then the value of L is 0, and therefore always we see a spherical movement of the electron, which basically represents the s subshell or the s orbital. Now if n is equal to 2, then L can have the values of 0 and 1. And therefore, it will have a s orbital because the value is 0, and then it will also have one more orbital because the value is 1. There is one more orbital that is seen, which is called as p. Now, if n is equal to 3, then L can have a values of 0, 1 and 2. And because there are 3 values for L, there can be 3 orbitals which are s, p and d. And if n is equal to 4, then the value of L can be 0, 1, 2 and 3. And then you see that there are 4 subshells or 4 orbitals which are s, p, d and ef. Now what is s, what is p, what is d and what is f? Now what is s, p, d, f shells look like? Now that is what is shown here. S will be spherical, p is always a dumbbell shaped structure, d is a double dumbbell shaped structure and f is a complex structure. Right? So that is all about our second quantum number, which is called as azimuthal quantum number. Now after we learn about the azimuthal quantum number, let's go to understand the third number, which is called as the magnetic quantum number. Now let's talk about the s subshell, s orbital, and we know that the electron is moving in a spherical fashion here. Now, will it have a x, y, z orientation? Of course, it has all of them and none of them, right? Now, in this particular case, I cannot say which orientation it is in. But let's talk about the p orbital, which has a shape of a dumbbell. If it is having a shape of a dumbbell, you can see that it will have a orientation. It can be lying in the x-axis, it can be along the z-axis, or it can move along the y-axis. Now, many times this axis also plays an important role because the probability of finding electrons is maximum in these regions, right? And therefore, it is going to affect the magnetic properties that we see in an atom. If you look at one more orbital like d orbital, it can have 5 different shapes like dxy, dxz, dz square, dyz, and dx square minus y square, right? And then if you look at one more suborbital like the f orbital, you see that it can have 7 different shapes that the electron can occupy. Now this number, which is going to tell us the specific orientation, is what we call as the magnetic quantum number. Magnetic quantum number is denoted by m and its values range from minus L to plus L. So let's just take a look at that. Suppose we are talking about a p orbital, and this p orbital has a value of 1, right? S is 0 and p orbital is 1. Now the values that it can take is minus 1, 0 and plus 1. So if it is lying in the x-axis, we say m is equal to 0. If it is lying in the y-axis, we call it as m is equal to 1, and z-axis would be minus 1. So this is about the magnetic quantum number. Let's come to the last quantum number, which is called as the spin quantum number. Spin quantum number is a number which can have only 2 values. Very simple one. Plus half and minus half. Now what does this tell? This basically tells us the spin of an electron within an orbital. So the electron is moving around the nucleus, but it is also spinning, and this spin is what we call as a spin quantum number. Now it can spin clockwise or anti-clockwise direction or the counterclockwise direction, and if it is moving in the counterclockwise direction and the clockwise direction, we call them as minus half and plus half respectively. So to describe an electron, we use all these 4 numbers: the principal, azimuthal, magnetic and the spin quantum number. And just like our home addresses, which cannot be the same for everyone, we also see that the electrons cannot have all the 4 quantum numbers the same. And this was first explained by Pauli, and this principle is what we call as the Pauli's exclusion principle. According to this principle, no two electrons in an atom can have all the 4 quantum numbers the same. Hence, every electron has its own address, its own set of quantum numbers through which we can know more about electrons in an atom. In our next video session, we will be talking more about the arrangement of electrons, how the electrons are arranged in various atoms, and are there any rules that the electrons follow when the electrons are getting arranged in an atom. So, see you all.